think it's counting. Yeah. Okay, back to your question, Alan. So if I have 2 beakers, and let's just pick, I guess alcohol. So, as in like disinfectant. So let's say that this one here is really strong stuff, 50%. This is pretty weak stuff. And I'm going to add them together because I don't want either number. I want something partway between, right? So I want to end up with, and then this stuff here, I want it to be 20%, okay? Does the question make sense? Okay, so this is what I have in the stockroom, these two bottles. And I'm going to add some of each together to get 20%. And the question is, how much do you want to have when you're all done? And let's just say we want to have 200 milliliters. So does that make sense? Do you understand the situation? Maybe I should say it that way. Okay. So the question is, how much of this and how much of this? What's that?
I'm going to listen to what you're saying. I'm still trying to write everything down and write it down.
Okay.
You're really fast. Nobody's ever told you that. Okay.
You good?
Sure.
Yeah.
Yes.
So we're just taking, again, you go to the stock room, you've got a whole jug of this, you've got a whole jug of that. We want to mix it up so that we have 200 mils of 20%, right? And first thing, a little bit of common sense. No way can we get to 5%, right? Because we're saying the weak stuff is that. And there's no way we could get to 70% because the strong stuff is that. So hopefully right up front, you recognize kind of what's possible and what's impossible, right? So the fact that we're somewhere between those says at least we can get there. And if I were exactly halfway between those two numbers, that means I have an even amount of each, right? Okay. But we're not. We're a little bit towards this side. So I'm hoping your intuition tells you we need more of this than that. No?
I don't have intuition in that.
Oh, I wouldn't put this under the math category, but, you know.
Or science either.
Yeah, okay. I need to work on that one, I guess. All right, so, but then how does the formula help us? So this is representing this. This is our second thing. It's representing that. So I'm going to call it the 1, the 2, and then this is my final. Okay? So this is this information. This is that. This is that. And you can see over on this side, I have C stands for concentration, V stands for volume. Okay? So my volume is 200 milliliters. My concentration is 20%. So those are just a matter of plugging them straight in. On this side, I know the concentration, but I don't know my volume 1. Here I know my concentration, but I don't know volume 2. So your first thought should be, I have two things that I don't know and only one equation and I can't get there. But going back to the common sense part, we know if I take some of this and some of this, it gives me that. I also could write it out this way. This plus this must be equal to this. Right? You can just picture that. You take the two things, pour some in, pour some in. It's got to be true. This plus this has got to be equal to that. So if I were just to do a little bit of algebra, and it doesn't matter if I want to move the V2 over or the V1 over, I just chose to do it that way. Now I can take this and I could run right over here and plug it into here, okay? So now I have 50 times 200 minus V1, V2, plus 10 times V sub 2. And I can do the multiplication here, so I'm going to have 4,000, right? Okay. And then you can see you'll probably need to do the distributed property there. So I'm going to have, nope, I will not have that number. What is it? 1,000, right? Maybe? 10,000, isn't it? There we go. 340, okay. Minus 50 times that, so this would be 50 V2 plus 10 10 V2 equals 4,000. So let's see, how do I want to do this? I guess I'm going to subtract this from both sides. And I can combine these. So I'm going to have negative 40 V2 equals negative 6,000. Okay with the algebra so far? And then divide by both sides by negative 40. A couple of you guys have that answer for me? Was it? Is it 1? That's a guess. Is it 150? Okay, good. Thank you. So what we know is now is that this here we have 150 mils of that. So how much of this do we have? 50, right? Because 50 plus that will give me that. Or we could have actually, stuck with the algebra. You'd come back over here and plug it in, and you'd get to 50 that way. So kind of, hopefully. So I'm hoping you can grab parts that are kind of like physically make sense. That you just know certain things have to add up. And so you're using the equation, but I'm hoping a lot of that can also be just a little bit intuitive to you. Okay. What's that?
That's how I guessed my answer.
Well, I'm glad you guessed right. Yeah. I'm hoping we can get. That's what I was afraid of. I can see a patient laying there. Are you the one who guesses on these? That's the way to instill patient confidence. One time I was giving a presentation at Boeing. They called it the most expensive meeting of the week. And this is when you had all the big cheeses that made weight bunch. But you explained to them why you wanted to change the airplane. And then, normally they give you bad time. Now we don't spend the money. So apparently I did a good job one time. He said, we can save money, save weight, and fix a problem. And I had the guy sold. And then I ended the phrase at one point. He asked the question, and I answered his question, or something like that. And whoa. He stops the whole meeting. I'm up front, right? Doing a little power. Actually, we didn't have PowerPoint then. We had transparencies. But anyhow, he said, you had it sold. And he said, you ruined it with something like that. He said, you blew our confidence and you just, boom, right there. So try to give your patients some confidence. Yeah, how many do I? Yeah, or something like that. 2 of these or something. Plus or minus 3. Okay. Let's see. Let's do the quiz. I still have like 3 more clicker questions for you. We'll do those last. Okay. What's that? Let's restart the quiz. That's an interesting idea. Now you said, well, good. Actually, the quizzes are the smallest part of your grade, right? You know that. And I recognize, when you come into, you may not quite be there, but the reason I do it is hopefully it's going to make questions and we'll iron out some of those little things. So it's intended to be more of a learning experience as opposed to how much do I know experience. The test is intended to be the how much you know kind of experience. Granted, you'll probably learn something out of it as well. But. Okay, so 2.5. So this is the last section we'll be doing here before the test. So on Monday, we would look at an equation and try to graph it. So we want to be able to see what it looks like, right? That was more the general direction of the questions. No, towards the end. Yeah. There's 3 questions I hope to ask you at the end. So the goal right now would be, turn the projector on might be helpful. Yeah, 2.5. And again, so it looks like half of you maybe have your books. Yeah, I sent out an email yesterday, but I got an email from the bookstore saying that they were there. So hopefully you can walk over there and get yourself a book. It'll be nice too. I won't need to be you guys can help me out here when you have your own books. So the goal is to take information and actually come up with the equation here today. That's the primary direction we're going to try to go, okay?
What page are we supposed to be on?
Can't help you. Well, let's see. I'm guessing my page numbers will be totally different than yours. But let's try that, since some of you have a book and we can experiment with that. In my book, it would be page 242 would be the beginning of the problems in 2.5. So, but I haven't had a chance to look through this printing, so I don't know what you guys end up with for page numbers.
Well, they don't label the chapters in these, like in the corners or anything like that. Like search through to find out what actual chapter you're on.
See, 1 point. This one should be 2.5 somehow.
Left-hand side, that's
It
the
says
title.
5.
Yeah.
Cool.
Yeah, if you look at the right page, does it tell you the... Okay. So, the basic two pieces of information, I think you'll figure it out in a little bit, but the basic two pieces of information, we're trying to do linear equations. We want to know the rate of change, or they're going to be giving us the rate of change. So in other words, that could be how fast things are going downhill. Okay, hopefully that's not your finances. Maybe this is what do you want to go downhill? Okay, so we'll have to work on that one. We can do it somehow though. So, but actually, maybe the mileage you're buying cars that get better mileage or something. Yeah. Okay, but this shows. So rate of change we talk about as being slope or m. That's how fast things are decreasing or increasing, right? So that's one piece of information. The other thing is we always need some kind of reference point or a starting point. And so a lot of times we will think about this as maybe being the y-intercept. So then that would be, that point right there. Okay. So in the first example, so again, I'm just running through what will be like your homework. Okay. They tell us these. They just right up front say, hey, this is 3/8. So of course, don't look at that picture too closely because it's negative. And they don't actually tell us the y-intercept itself, but they tell us 1 point along the line. Okay. So they tell us -8, 2. Yeah, there we go. Yeah, that's pretty clever. Where in the world did I get that? 3/4. Okay, there we go. So the whole question is, there's two formulas we'll be using in this one. We've already talked about y equals mx plus b, and this is what's called the slope-intercept. So that's the slope-intercept equation. The other one the book talks about, and in general this is the one I would say that's the one to memorize, okay? But the other one we have is that y minus y sub 1 equals m times x minus x sub 1 plus... No, that part's not there. Okay, just like that. This one is known as the point slope. Point slope equation, okay? So again, this is the one I tend to I think it's the one most worth memorizing, but you'll have to do a few using this as well. So in this one here, I want to use the point slope formula, and it's a hair easier when they give you a point. Okay? So that's what I want to show you first. And it's really just a matter of plugging the numbers in. So we're saying this is x and this is y, or if you want, you could put the subscripts 1 and 1 on that. So we have y minus y sub 1 is 2 equals m. Right there, they just gave it to us. It's 3/4. X minus, and here's x sub 1, which is -8. And again, I tend to use parentheses right there where the variables are at. So it's like I'm filling in a blank. Okay? down a little bit, not much. There, he's looking out the window too. Is everyone comfortable how we plug those three numbers in? Okay. So all that's left now is to distribute this. So over here I have y minus 2 equals 3/4 x. And this is actually a positive 8, right? Everyone can see that? Okay, so then 3/4, so I have plus 3/4 times 8 over 1. Don't mind if I do it that way. Okay. Oh, you're already doing the math for me? Good, thank you. Okay, so we have y minus 2 equals 3/4 x plus 6. And then we just need to add the 2 to both sides. So y is equal to 3/4 x plus 8. So there we go. They just wanted us to use the point slope equation to come up with a slope-intercept form. Okay. So there you go. There's our little equation from that beginning information. Good there? Okay. All right. So now this one says we have same slope as last time. We have 1 point again. So we're given the same information. This time we want to use slope-intercept equation instead. So we're doing we want the exact same outcome, but we're just using this equation instead of this equation, right? Okay. So first, the obvious part, we can plug right in our slope. Now again, this is x and this is y, right? So temporarily, only temporarily, we'll plug in the y right here. And I'll put the x right here. Like that. Everyone okay with how we plug things in? So I have 3 equals, and again, this is going to just cancel out. So this will become a negative 3 plus b. And then I can add 3 to both sides so that I end up with b equals, what was that? The negative 3. We have this negative right here, and that part doesn't go. It's still there. Well, it's actually the 4s that's being canceled out, not the negative. So I have 3/4 times negative 4 over 1. So it's just the 4 going away. Okay? Now, that means I have my slope, I have my y-intercept. Well, you agree this goes away, right? So over here I actually have 3 plus 3. Well, it's easy when you look at those two guys to cancel out. Yeah, no, I get that. Yeah. No, that's a fair question. Something I would likely make a mistake on anyway. So, okay, now let's fill in. No, we have y equals, now here's our m again, m, x plus, and then there's the b. So there's our equation, slope-intercept form. And again, notice we only use the 3 and the 4 here temporarily to help us get to this point. In our final answer, we don't have the 3 and the negative 4. Okay? That is simply 1 point along the way. All right? Okay, and I'm guessing a lot of you remember doing this, but do you remember the slope equation itself? Why would I? Now, this was actually a separate example from this. Is that kind of where your question was? Yeah. Yeah. Yeah, there are slightly different problems, 2 different ways to get there. Okay? Now, this is the most likely situation. It's not very often they actually tell you what the slope is. What's more likely, remember on Monday I showed you a bunch of data, health data for Norway, right? Well, I originally showed it for all the countries, right? But then I showed you a table, I think, with dates and life expectancy in Norway. Do you remember that? So it's just a whole list of X and Y's, X and Y's, X and Y's. Okay? So if you're trying to find the equation that would model that, what you can do is actually grab a pair of X and Y's, which I have up there, right? The 8 and negative 1. And the 4 and 3. So just for a moment, kind of graph it out here. So here's 8, negative 1 would be right there. And 4 and 3 about there. So there would be our graph. Now the reality is, if you really have a bunch of data, a lot of times it looks like this. You're going to have other points along here. Kind of like that. So, but in this case, we said, okay, let's focus on this point and this point where we were only given that information. Good? So this is the more likely situation. So what we need to do is first, we're going to find the slope. Once we have that, we're going to do like we just did a minute ago. Plug it in, find the whole equation, okay? So I'm going to call this one x1, y1, and x2, y2. And this is arbitrary, but just don't mix the pairs. So if you want to call these the 2's and these the 1's, that's fine. Okay. So you can see our equation then is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's go plug them all in. And again, I think if you use parentheses, you'll have better luck when you run into negative signs, okay? So here's my y2 right there is a 3. My y1 is a negative 1. My x2 is a 4. My x1 is a 8. So we'll have 4 over negative 4. So our slope is negative 1. Okay? So first step. Second step, we would have y equals mx plus b. And we now know the m is negative 1. We need to plug in an x and a y, right? You can pick either pair. It doesn't matter. If one is an easier pair, like having 1's and 0's, that's what you want to pick. Okay. In this case, I don't think it matters so much. So here, let's do this one. I'll put in the 4 right here. I'll grab my 3 and put it here. So then I'm going to go plus 4, plus 4. And so now I can see that b is equal to 7, right? So we're almost done. What we wanted was an equation in slope-intercept form. So here we go. Y equals m, which is negative 1, x plus b, which is 7. So this guy right there, and this thing comes right down in there. So we just plug them in, and that's the equation. So what we're saying is that y equals negative x plus 7 would model that data. Okay? Yeah?
I have a question about this so that I can do y1 minus y2 and then x1 minus x2.
You know what? This is written several ways. And again, it doesn't matter because this notation right here is arbitrary.
But it would work either way.
It does. That's right. I could go ahead and make these the 1's, make these the 2's, or I could switch them in the equation here. And yeah, everything's going to work out just great. Okay. The only thing is you don't want to somehow mix the 8 with the 3 or the negative 1 with the 4. That would mess it all up. Okay. Now, any idea why we do that besides it's fun? Politely disagreeing with that statement. What was that?
So you can graph it?
Well, and which is part of the fun, right? That we could graph it better, you know. But why would we mess around with doing this stuff? And the answer is so we can predict the future, okay? Well, a lot of times this might be years, for example, right? So you want to know where things are going, right? Are home prices going up or going down? Or where would, if this trend continues, what's going to be happening out 5 years in the future, right? So to find out what that value is now, let's say that this is, see, here was 8. So we want to know what's going on at 12, okay? Whether that be years or whatever. So I can come to this equation now. I can grab this 12. And this is an x value, right? Okay. So I come right over here. I can stick my 12 in there. So now I have negative 12 plus 7. So then y would be equal to negative 5, right? So we're saying this, if I were to continue where I think that's going, we're going to be down here now at negative 5. Now, when you try this with the stock market, actually, I'll show you a picture of that later. I don't think I have it right now, but it's a little hit and miss. If you could get it to work, you'd make buco bucks, okay? Right? Because you look at it and say, okay, I'm going to buy down here, and then I'm going to hang out until it comes back up to here, right? All right, are we doing fine so far? Okay, good. We're almost done with this, really. So if I have this equation here, and if I were to graph it, y-intercept is 2, so I'd go 1, 2, put a dot. I'd go up 3, right, my rise over the run. 1, 2, 3, and then 4. 1, 2, 4. So there's my equation, right? I mean, my line for the equation. Now, if I have another one, let's see if I can. That was not what I was trying to achieve. That's closer, okay? You can imagine I'm trying to tell you they're parallel, right? So what do we know about this equation? And if these lines are truly parallel, what we know right away is that the slope is also 3/4. Okay? Now, looking at it, you could kind of guess maybe it's, I don't know, negative 3 or something. We don't know for sure. So, but the first thing I want you to know is that if two lines are parallel, then you know that the slopes are the same, okay? And I think that's pretty easy to imagine when you just look at the picture, right? So now if I were to run another one through here, let's say I have a line going right through there. What can I say about the slope of this line? And the answer is, if this is crossing at 90 degrees here, in other words, if it's perpendicular, you guys recognize that perpendicular symbol? Maybe, maybe not. So if it's perpendicular, what you know is the slope will be the negative reciprocal. So I flip the sign on it and turn it upside down. So I know the slope of that would be negative 4/3. So you do two things. You flip it and you change the sign. In this case, we had positive, so when I flipped it, it became negative, right? So it's two things to remember. Flip, change sign. So everyone's fine with that? So here's the way they're going to ask you in the homework. They're going to give you a point, Let's say find an equation. And they're going to say it goes through a point. So let's just pick 3, 4. And they're going to say it's either parallel or perpendicular to. So let's pick the perpendicular option to another equation. Well, here, let's borrow this one. Perpendicular to y equals 3/4 x plus 2. Okay? So all we do, the only reason this is given is so we can steal this part and go perpendicular to it, which means m will be equal to -4/3, like we talked about, right? Now that you have your slope, and now that you have a point, you come over here and you do the same problem you've been doing, right? Are you with me on that? You're going to do the y equals mx plus b. We're going to put in our slope. We're going to put in an x. We're going to put in the y. And we'll solve for b, just like we've been doing. Okay? This 2 over here doesn't matter at all. That was telling us something about another line. We're making an equation for our own line that happened to go through that point. Okay? Is there any reason to finish this at this point? No. Okay. Oh, that's funny. I didn't know I had this slide here. If you see this one here, they want it perpendicular to that. What's the slope of this one right here? Yeah, you've got to bring almost. We're going to bring the 8 over, right? And you'll have to do one more step. One more step after the one you just did. So you're going to 8x minus 3y equals 7. So I think what you did was you brought the 8x over, which is good. And we have one more step, though, to actually know what the slope is. Yeah, divide by the -3. So our slope then that we care about is the 8/3 part. This -7/3, again, it doesn't pertain to our problem, right? All we cared about is now we can grab this like we did here and go use it. Okay? Yeah. What was that? So at this point, I wasn't going to do that whole problem unless you would like to. Can I erase all this? Okay. Well, then I think we've got time for those 3 questions. So Mariah, did you really want to do some extra quiz questions? Well, I didn't know if maybe we almost have enough time we could. So actually, though, let me turn this little guy off here.